Hello everyone, welcome back to another Ethernet IP instructional video from TR Electronic. In this short video, we want to highlight the different ways that you can preset the position value from your TR Electronic encoder. This video is going to focus specifically on our Series 2 or Generation 2 rotary encoders. During the commissioning of your equipment, it is very likely that you will need to change the position that the encoder is outputting to a custom desired value. In all applications, you will mount the encoder and couple the encoder's shaft to your monitored shaft. Next, you may need to synchronize the physical real-world position of your equipment with the encoder's measuring system. Commonly, this will involve manually jogging the equipment to a known location or measurement, and either zeroing the value from the encoder or defining your own custom value. Historically, over Ethernet IP networks, this function is done using Class 3 explicit message instructions between the controller and the encoder. Although it is very common, it is not the only or even most convenient method available from TR Electronic today. Let's take a closer look. I've already set the IP address of my encoder and confirmed that I have communication with my controller. If you need information on how to do this necessary step, please reference our video titled CXX582M Ethernet IP Encoder Basic Setup Tutorial before proceeding. You can find it on our YouTube page, and I'll also post a link to it in the video description field below. In RSLogix 5000, right-click on the rotary encoder device and open the Device Properties window. We need to change or verify that we have configured the device's I/O connections to include an output assembly. In order to do this, you need to be in an offline state with the controller. If you click on the Change box located under Module Definition, it will bring up the Connections window. By widening the columns, you can see predefined connection types within the EDS file. For this example, select Position Value 32-bit plus Preset 32-bit. Notice how you have 5 input short integers and 5 output short integers. These 5 output bytes are how you will perform the preset function to the encoder. As a side note, you can also select Position Value 64-bit plus Preset 64-bit. The preset will function the same way with both connections, but you will need to reference Chapter 7.2 Assembly in the device manual for the correct bit mapping of that connection type. Now that we have selected Position Value 32-bit plus Preset 32-bit, go to your controller tags and find your device. The output assembly is denoted by a :01 after the device name. The first 4 bytes of data are used to define the preset value that you want to write to the device, and the 5th byte is used to perform that preset. Download and go online with the controller again, and go back to your output assembly in controller tags. Leave the first 4 bytes as 0 values, then define byte 4 as a value of 1. The moment you hit enter, the position value will change to 0, and you can verify your input assembly data is now showing a position value of 0. Then go back and set the tag value of byte 4 to 0 again. Now try with your own value, keeping in mind that it must be a value within the measuring range of your device's scaling parameters. For example, if you've programmed your encoder to count between 0 and 359, you cannot ask it to output a value exceeding 359. I've chosen a value of 8 million, but first I need to enter that value into my output assembly. This example shows how you can quickly create a rung of code to copy your preset value directly into your output assembly and actuate the preset. Enter a value in the Move Instruction source tag New Output Assembly Preset Value. The value is then moved to tag Output Assembly Preset Value, which is being copied to the output assembly starting at the least significant byte 0 for a length of 4 bytes. Using an output energize instruction tied to tag Preset Copy Done, we ensure that the file synchronous copy is completed before saving the new preset value. Using another output energize, this time tied to bit 0 of output assembly byte 4, which is the preset control bit, the new value is applied to the measuring system permanently. Alternatively, you can use your programmer's calculator to convert your desired position value to hexadecimal, then simply enter the value 2 digits per output assembly tag, beginning with your least significant byte 0 and working your way down to the most significant byte 3. Lastly, set the value of byte 4 to 1 and hit enter. Now reference back to your input assembly position data and it will be set to the desired value. This was pretty simple to do, but in the case that you want to use position and velocity data in your input assembly, you can see that the output assembly data is no longer available. In this case, you need to preset the encoder using Class 3 explicit message instructions. This method is used across all of our Ethernet IP devices, regardless of the selected I/O connections. Let's go over an example of how this can be done. Just to recap, we have now changed our connection type from position value 32-bit plus preset 32-bit to position value 32-bit plus velocity. Go to your ladder logic routine window and start by dragging in an empty rung. Add an XIC input instruction followed by a message instruction. Double-click the question mark above the XIC and type Write Preset. Hit enter, then right-click and select New Write Preset. The new tag window will appear, and as long as your data type is Boolean and your scope is set correctly, you can simply click Create. Next, double-click the question mark in the message instruction to create a tag called Preset Message. When the new tag window appears, it should have defaulted the data type to Message. Just like the first tag, set your scope and click Create. Now we need to configure the message instruction to perform our desired parameter change. Click the box with the 3 dots and the configuration window will appear. Referencing the device's manual, we can find the values that we need for the corresponding parameter. Set the service type to Set Attribute Single, Instance to 1, Class to 23, and Attribute to 13. Now click the new tag box and create a tag called Preset Value of a data type double integer. Double check your scope is correct, then click Create. Now select that tag as your source. Your source is the value that will be written to the encoder via this message instruction. We will define it shortly, but the manual indicates that the source length needs to be 4 bytes. If you do not set this correctly, the message instruction may error, and you can look here for the error text. It will indicate whether the source length is too small or too large. Set the communication path which you want to preset, always being certain that if you're using multiple encoders, you've selected the correct device. Now find your tag preset value in your controller tags and enter your desired preset value. I'll use 16 million this time. Our next step is to create our accept parameter message, which will save the value to the encoder. If you do not do this step, and power is cycled to the encoder, any previous preset value that was applied will be lost. Drag in a new branch and arrange it like shown. Then add an XIC input instruction and a message instruction. Double-click the question mark on the XIC and select the Done bit from the preset message that we already created. Then, create your message instruction tag, but this time call the tag Accept Parameter Message. Configure it using the values in the manual. Once more, set the service type to Set Attribute Single, the instance to 1, class to 23, but this time set the attribute to 70. Click the new tag box and create a source tag called Accept Parameter of a data type short integer. Choose that tag as your source and set the source length of the message to 1 byte. Lastly, set your communication path to the encoder. Now go to your controller tags, find the source tag accept parameter that you just created, and set the value to any number between 1 and 255. Now download your project to the controller and go online. In your ladder logic routine, toggle the Write Preset XIC, and if the message instructions were successful, you will see the done bits go high. Go to your input assembly and verify that your new position has been saved. That's all we have time for today. If you found this video helpful, please like and subscribe for more upcoming videos. If you're looking for more information on our products and services, please visit us on the web at www.trelectronic.com. See you next time.